Hi everybody, it's time for video 2 of lecture module 7. It's still Mars time and we are going to take a look at the large-scale global features on Mars and discuss the largest canyon and the tallest mountain in the entire solar system. They both live on Mars. If you want to know what's coming up in this video, here's our template. I'm just going to jump right into the material though. And let's take a look at some of the global views of Mars, but this time let's take a look at the Martian topography. So what is topography? Really, we're just looking at the elevation. So down here, we are looking at Mars's topography. This is measured by the Mars Orbiter Laser Altimeter, also called MOLA, and this was or is on board the NASA Mars Global Surveyor (MGS) spacecraft, which has been in operation since the late 90s. So what we're seeing here are elevation, where blue is low elevation, and red, the red and white colors are high elevation. If you're interested, there's a scale bar right there. And very obviously, Mars is divided into lowlands and highlands based on what hemisphere of the planet you're in. So you can see that the northern part of Mars are all lowlands. They, on average, lie several kilometers, about 5 kilometers lower than the Southern Highlands. So we call the northern part of the planet the Northern Lowlands. We can look at the Northern Lowlands and we see that there are fewer craters, which indicates that it's a younger surface. The plains that are there, because it's sort of rolling volcanic plains, they are volcanic in origin, so we can associate the rocks with volcanism or volcanic created, and they are not unlike the lunar Maria, except it's the entire northern hemisphere of Mars. Perhaps early on, or about 3 billion years ago, something very large hit Mars and created a huge dichotomy between the northern lowlands and the southern highlands. The southern highlands are about 5 kilometers on average above the northern lowlands. They are more mountainous, more heavily cratered, and therefore older. What are the ages? So the northern lowlands, we expect that crater counting gives us an age of about 3 billion years. The southern highlands, the crater counting gives us an age of about 4 billion years. And this time period of about 4 billion years ago to 3 billion years ago was a very interesting time on Mars. There were lots of changes happening on Mars, and all of this is probably not unrelated with what's going on with the surface ages. It was a very hectic time about 4 billion to 3 billion years ago on Mars. And there's a dramatic change between the northern lowlands and the southern highlands. If you look at the topography, you can see that there is essentially, it doesn't run directly along the equator, but very close to the equator, there's almost like a 5 kilometer cliff, or a very rapid change from the highlands to the lowlands. Some other features that we're about to launch into, you can see the very highest regions on Mars are located here, these equatorial regions, and these right here are the 4 biggest volcanoes on Mars. This is called the Tharsis Bulge, and then the lowest point on Mars is actually in the Southern Highlands, and this is called the Hellas Basin right here. Let's go ahead and take a closer look. So now we've changed to a global view because I want to see this in a non-Mercator projection so we can wrap around and see just how big some of these features are. So let's focus in on the Tharsis Bulge and the Hellas Basin. So the Hellas Basin right here, what is this? See how it's nice and round? This is another huge impact basin. On Mars, we saw the Hellas Basin. I didn't really talk about it. On the moon, you have the South Polar Aitken Basin as the largest impact basin. And for Mars, the largest impact basin is called the Hellas Basin. It dates to an age of about 4 billion years ago. This is right at the start of the late heavy bombardment. So Mars got whacked real hard by some large impactor. How big is this? This is about 2,300 kilometers across from edge to edge, and it goes down about 8 kilometers deep, giving us the lowest point on Mars within the Hellas Basin. A long time ago, when Mars could actually support liquid water on its surface, the Hellas Basin could have been an ocean. So you can imagine whenever you have something that is going to come in and whack Mars, and be large enough to create the Hellas Basin. That's going to cause some major restructuring of the crust of Mars through seismic waves traveling through the surface. And with such a large impactor, it could have a pretty large impact on the crust of Mars. So if you go directly through the planet and go to the other side, that's where you see the Tharsis Bulge. They're both about the same age. They're thought to be created essentially by the impact event that created the Hellas Basin, where this region right here got uplifted by all the seismic activity that streamed through the planet and the creation of the Hellas Basin. So the Tharsis Bulge, this is roughly the size of North America. It lies right around the equator of Mars, and it is an uplifted plateau that is about 10 kilometers above the rest of the average Martian surface. So it is significantly higher up. And yes, it is on the direct opposite side of the planet, what we call diametrically opposite, or if you want to use the really fancy term, it is antipodal to the Hellas Basin. Now let's take a look at some of the features. These are both associated with the Tharsis Bulge. We're going to take a look at the largest mountain in the solar system. It's found on Mars, and the largest canyon in the solar system, also found on Mars. Let's go ahead and jump in with the largest canyon. And we can see that here is a reconstructed global view using Viking data. You can see this huge scar on Mars. This right here is a giant canyon. It's called Valles Marineris. This huge canyon is called Valles Marineris. It's actually named the Mariner value, if you wanted to translate that. And it is an absolutely huge canyon. It is just to the east of the Tharsis Bulge. So right here would be the Tharsis Bulge. Here you can see two very large shield volcanoes that are located on the Tharsis Bulge. But let's really take a look at the Valles Marineris. So I've just put on a different view where we have superimposed a map of the United States on Valles Marineris. It would stretch all the way from the west coast of the Pacific all the way to the east coast. That is how large this canyon is. Taking a closer look, now you can see it in detail. So you can get a lot of the details of what it looks like. And you can see this long jagged scar essentially stretched from the Pacific Ocean west coast to the Atlantic Ocean east coast. It runs 4,000 kilometers across. So that is pretty darn big. It is 120 kilometers wide, and it is 7 kilometers deep. This is the largest canyon in the solar system, and it doesn't really have a whole lot of competition. Let's compare it to the largest canyon on Earth, the Grand Canyon. The Grand Canyon, by comparison, is about a tenth as long, only 446 kilometers long. It's about a quarter as deep. So it's only about 30, or a quarter as wide. It's only about 30 kilometers wide. And the Grand Canyon is only about 2 kilometers deep, instead of the 7 kilometers deep that the Valles Marineris is. So an absolutely enormous canyon. The largest, and anytime I'm saying largest, good things to know for exams, canyon in the solar system. And the name literally translates as the Mariner Valley. It was named because NASA's they flew 10 Mariner missions. And these were the first spacecraft to visit Venus and Mars, the first time we really got to see Valles Marineris. And again, it's located to the east of the Tharsis Bulge, and the creation of this canyon is not by water. It is thought to be as that tectonic uplift created the Tharsis Bulge. The surrounding crust would have been heavily affected, and thought that this just literally just split apart, forming a giant canyon. Now let's go ahead and zoom in and look at some of the volcanoes on Mars. And the ones that I'm going to talk about, they're distributed all over the surface of Mars, shield volcanoes are, but I want to focus in on the biggest ones because they're all located on the Tharsis Bulge. So if we go to the Tharsis Bulge, you'll see lots of shield volcanoes of absolutely enormous sizes. So it has the largest shield volcanoes, the biggest of which is Olympus Mons. The three next biggest ones are also located here, and they have these cool names, the Acreus, Pavonis, and Arsia Mons. And we'll take a look at those here in a second. The tallest of all of them is Olympus Mons, and this is absolutely a monster of a volcano, a monster of a mountain. Because remember, volcanoes are mountains. So this is the largest mountain in the solar system. So here we have Olympus Mons. It is 700 kilometers across from side to side, which gives it a total surface area of about the size of Arizona. So there's Arizona superimposed. It rises 25 kilometers above the surrounding plains, which makes it 3 times taller than Mount Everest, 3 times the altitude of Mount Everest. It makes it 2.5 times taller than the largest mountain on Earth, Mauna Kea. And I said largest mountain. Sure, Everest has the highest elevation, but the biggest mountain from its base at the ocean floor to the peak is Mauna Kea. And Olympus Mons is 2.5 times larger than that. This caldera at the top is 80 kilometers across. Now, just sort of a cool fact for the curious, why are Martian mountains, why are Martian volcanoes, why is Olympus Mars so much larger than any volcano we see on Earth? Simply has to do, Mars has lower surface gravity than the Earth. It's a much smaller planet, which allows the mountains to grow taller. Now let's go ahead and zoom out. So here's Olympus Mars. So that's the size of Arizona. Here are those other 3 volcanoes that I mentioned. Just sort of a cool fact about Olympus Mons being 25 kilometers tall. It will poke up and out of the clouds, and it effectively pokes out of the Martian atmosphere. The air is extremely thin up there, but it is such a large volcano, you can almost consider it as poking out of the Martian atmosphere. It is a giant shield volcano, and it's surrounded by cliffs that can be upwards of 8 kilometers in height, but are roughly on average about 5-ish kilometers or so. And I want to give you another view. This is again using MOLA data where we have the altitude of things. We know the topography very, very well. So they did a computer reconstruction of what this would look like if you were on a spacecraft flying over Mars. And here is Olympus Mons, those steep cliffs at the base, size of Arizona, gentle rise because it's a shield volcano, and a caldera at the top. So with all these monster volcanoes, they're on Mars. We have to ask a question. Is there still active volcanism on Mars? If I look at Olympus Mons right here, I don't see any craters on it, which tells me that it has a fairly young surface. We have been studying Mars for quite a while. We've not seen any active eruptions or any evidence that there have been recent active eruptions, but the surface of Olympus Mons is so large we can do some crater counting. So we know the age of the surface of this volcano. That dates to about 100 to 200 million years old, which means that this volcano was active as recently as 100 to 200 million years ago. That's extraordinarily young. The dinosaurs were alive on Earth while volcanoes were erupting on Mars. Let that sink in for a second. So Mars, while we don't see any active volcanism right now, it was recently volcanically active. And it might just be that volcanoes on Mars only do periodic, like every couple 100 million years they erupt, because again, if you look at the distribution of volcanoes on Mars, you don't really see any signs of global plate tectonics. You can make the argument that the Tharsis Bulge was a single plate that was created when it formed, and that's why you can see some of the volcanoes as a chain. But that's not even, that's only a hypothesis, and it would only be a single plate and not the same as the plate tectonics we have here on Earth. So we basically now just have a solid crust, which means that volcanism is going to behave differently on Mars, and it could just be that it's a periodic thing that happens every couple 100 million years. And that's it for that segment on Mars. The next time we're going to dive into the Martian atmosphere. Thank you for tuning in. And I hope you enjoyed learning about the largest canyon and the largest mountain in the solar system.